All right, welcome Algebra 2B students. It's teacher Kevin here. We're going to go over notes. The learning target is I can convert vertex form to standard form for quadratic equations. So hopefully you remember standard form. Looks like sometimes we did y equals ax squared plus bx plus c. Sometimes we did ax squared plus bx plus c equals 0. We're going to go back to y equals. But then vertex form, if you're wondering what is vertex form, we're going to have that on the next page. You may have seen it. I can't remember if we covered it in the notes or not, but we will have that on the next page there. So with our warm-up here, we're going to evaluate each expression. And I encourage you to pause the video and try these out. But here I go. So one thing we want to remember is that we need to follow the order of operations here. So order of operations is going to be important. Some people do PEMDAS. Oops, sorry, let's write that a little more nicely. All right, that's a little bit nicer. So we have to remember order of operations. Some people do order of operations as PEMDAS. I personally like GMA. There's other ways to remember it, but when we're looking here at number 1, 10 plus 2, we have an operation in the parentheses or the grouping symbol. We have 10 plus 2. So before we deal with that exponent, we need to calculate 10 plus 2. So the exponent outside is just going to wait for its turn in the order of operations. 10 plus 2 is 12. And now we can do the exponent. That's our last operation, but we can do that exponent. 12 to the second power is 12 times 12. And that is 144. So that's it for number 1. If you haven't tried number 2, I encourage you to pause the video, see what you can do on number 2. But here I go. So same thing, we're going to do the parentheses or the grouping symbol first. We have inside there 20 plus 5. So before we square, before we do the exponent, we'll add inside the parentheses, inside the group. And then we'll raise that result to the second power. 25 squared, or 25 times 25, is 625. That's it. And then number 3, same idea. Start inside the parentheses of the grouping symbol. We have 3 plus 0. Before we do the exponent, 3 plus 0 is just 3. And then 3 to the second power, 3 times 3 would give you 9. Right? So hopefully not too bad so far. But we'll get into number 4. You can see we have variables. We've got those letters in there. But yeah, so noticing that each of these warm-up problems, we had a sum, we had addition inside parentheses, and then we had an exponent of 2 outside the parentheses. Number 4 is a very similar setup here. So number 4 says, is the following equation always true, sometimes true, or never true? M plus n in the parentheses, and then the exponent 2 outside, that's equal to m squared plus n squared. So is that always true that those two things are equal? Is it sometimes true that they're equal, or is it never true? Pause the video, think about that. So to help me answer this question, what I'm going to do is I'm going to say, well, let's consider number 1. Because number 1 was very similar. M would be 10, n would be 2. So if we do 10 plus 2 squared, 10 plus 2 in the parentheses, squared outside, exponent outside parentheses, is that the same if we just had the first number 10 squared plus the second number 2 squared? Well, we know that from what we did, our work on number 1, we got 144 when we followed the order of operations. But if we follow the order of operations on the right side, the addition would be second. We would do the exponents first. So this would be 10 times 10 would be 100. We would save the addition for after we do the exponents. 2 squared, 2 times 2 would be 4. So this would come out to 104. So is 144 equal to 104? That is false. That is not true. So how that helps me answer number 4, I can say, well, it's not always true. If it was always true, it would work with the 10 and the 2. 10 plus 2 in the parentheses squared would be the same as 10 squared plus 2 squared outside the parentheses, if it was always true. But it came out to 144 equals 104, which is not true. So I go, okay, well, I've got some other examples, so I'll check number 2 also. Okay, so the same way that I checked number 1, I could check number 2. I know that on the left, the 20 plus 5 in the parentheses squared, we did that. and that came out to the 625. But what if we just squared the 20 and the 5 individually and then added? Would that be the same? That's what this equation is asking us. Could you square m and n individually, then add? Well, if we break that down, 20 squared is 400, and 5 squared is 25, and if we add those together, we get 425. So is that equal to 625? No, that's false. So again, I'm sitting at, well, it's not always true. This equation here is not always true. Right now, I'm not sure, is it sometimes true or never true? So I have one more example we've done together that I can check out. We can try the 3 plus 0, and I'll do that now. So here we go. 3 plus 0 in the parentheses squared. We know from number 3 that gave us 9. We did the work up above. But if we square the numbers individually, then add, let's see, 3 squared alone is 9. 0 squared, 0 times 0 is 0, and then 9 plus 0 would be 9. Is 9 equal to 9? Yeah, hey, that worked out. So sometimes this is true. That'd be my answer here. It is sometimes true. Generally speaking, though, I want us to be careful, because this equation right here, this is a very common mistake that students will commit, that they'll say, oh, I think I can distribute the exponent. And to that I would say, generally speaking, exponents do not distribute over addition or subtraction. I'll write that out. Well, let's see if I can write this out. Okay, there you go. So there it is written out. Generally, exponents do not distribute over addition. If this was something like, if we changed this up and it was m plus n, and we were multiplying by 2 times 2, then I could distribute and do 2 times m and 2 times n. But that's multiplication over addition. That's not an exponent over addition. So yeah, just please be aware of that. Whoops, I think I lost some things here. We said that's sometimes true. Yeah, just be aware of that, please. It's such a common mistake in algebra when you don't have the numbers, when you just have variables, that students think you can do that. So, oops, and we also lost over here. Sorry, so that was true. Okay, so I'm going to move on here next to how are we going to do this thing called vertex form to standard form. We'll get a little bit closer to that. All right, so to the next section here, we've got the figure to the right is supposed to be a square split into 4 smaller rectangles, and question number 5 asks us, what is the base of the big square? So I'm going to say here, maybe the top is the big square. And so what's the base? Like, what's the length of that base? Well, if we had a number here, like if we pretend like that was 10, and then, oops, not sure what's happening with the ink here, but if we pretend that was 10 on the top, that part was 10 and the other part was 8, the whole thing would be 10 plus 8, or 18. But that's not because of the 10, we would just add those. So really it would be x plus 8 would be the entire top side. So x plus 8 would be the entire base of the big square. What's the height of the big square? Well, maybe the height would be the left. So a similar idea here, whatever x is right here, I would add that to the 8 that's below it to get a total length of x plus 8 for that left side. So maybe that's the height. Okay. Keep in mind, base and height, those are going to be sides of the rectangle, but which one's the base, which one's the height? Those are generally interchangeable. But number 7 asks us to fill in the areas for each smaller rectangle. So if you remember, area formula for a rectangle is just base times height. You basically just multiply one side times the other side. But so for each smaller rectangle, I'm just going to take one side of the smaller rectangle times the other side. So we can do these. We got 4 smaller rectangles, 4 smaller boxes. We can do these in any order, but I like to do it left to right, top to bottom, like I read English. So if I start in the top left, I have the base would be x and the height would be x. So it would be x times x, which is not x. A lot of students want to say that's x. I go, is 5 times 5 equal to 5? Is 6 times 6 equal to 6? No. X times x is x squared. Whoops, x squared. And I hope we would remember that from our quadratic equations when we have x squared there. Top right box could be 8 on the top multiplied by the x over here on the left, or x on the left times 8 on the top, but either way 8 times x or x times 8, and we just write that as 8x. And then bottom left box maybe is the x on the top times the 8 on the left, or 8 on the left times x on the top, but that's another 8x for the area of that bottom left box. And then the bottom right box, we've got 8 on the top, we've got 8 on the left. It's one of those 8s times the other 8, so the area of that rectangle on the bottom right is 8 times 8, or 64. So that was number 7. We filled those in. And then, the area of the big square then, the overall big rectangle, there's a couple different ways we could do this. So one way to do this would be just to say, well, hey, remember area of a rectangle is just the base times the height. And in number 5 and number 6, we said the base was x plus 8 and the height was x plus 8. So we could just say take the binomial x plus 8, multiply it by the same binomial x plus 8. If we want, we could say it's this binomial x plus 8 times itself. So we could say we're squaring the binomial x plus 8. But if we want to change this, if we want this in a normal way, if we want this in standard form, what we can do is we can add all the smaller rectangles. So yeah, if we add those smaller boxes together, because the idea is we got the x squared, that's the area of that top left box, and we got the 8x and the 8x and the 64. Those are the areas for all those smaller rectangles, all those smaller boxes. So if you want the area of the big rectangle, one strategy is to add up the areas for all the smaller rectangles, add all the smaller boxes. So x squared plus 8x plus 8x plus 64. And here you might know that we can combine 8x with 8x. We don't combine that with the x squared though. So we got x squared plus 16x, if I can write here, plus 64. So this would be real quick here. This is two ways to express the area of that overall rectangle. And I'll just mention here the x plus 8 squared. This would be more like vertex form, just relating this to the learning target. To convert between vertex form and standard form. X plus 8 squared like that would be what vertex form looks like more. And we know standard form, ax squared plus bx plus c, that's what our x squared plus 16x plus 64 would be like. So yeah, so relating it to the learning target, we're gonna have more examples where we have something like the x plus 8 in parentheses squared, and then we'll do the multiplication and we'll get the x squared plus 16x plus 64. Okay. Now, if you want, there's going to be a lot of having the parentheses, having addition in the parentheses, having the square, the exponent of 2 outside the parentheses. So if you want to do this box method here, this area model, this box method that we've got here, that's a good strategy. It's a visual strategy. If you're the type of person that says, hey, you know what, I can deal with formulas, I like shortcuts, there is a shortcut formula for this. If you have this binomial, m plus n, and you square this, remember up above what we said, it's not just m squared plus n squared. I mean, sometimes, but generally, m plus n in the parentheses squared is not just m squared plus n squared, but instead what it equals, you do get m squared as part of this. You do get, let me rewrite that too, you do get n squared as part of this, but there's more. There is what's often referred to as the middle term. It'd be 2 times m times n. So that's the part that a lot of people forget if they think that they can just distribute the exponent. I go, nope, doesn't work that way. But you can say that m plus n in the parentheses squared is m squared plus 2 times m times n plus n squared. I'll say one more thing before we go to the next page. In the previous example, we would have had, it was x plus 8, and we were squaring that. So this would have been the first thing squared, that was x squared, plus 2 times the first thing, which was x, times the second thing, which was 8. Let me rewrite that, 8. And that's the 2 times 8, that's the 16, along with x. and then plus the second thing squared. Well, the 8 squared, that's the 64. So if you like that formula, if it makes sense to you, you have to remember it. But it is a nice quick way to say, hey, I'm going to square the parentheses. I'm going to square the sum, m plus n or x plus 8 or something like that. But okay, now I'll go to the next page. Okay, so at the top of the next page, it says recall. I don't remember if we actually went over this in class before, but maybe you've seen this. So recall or be informed that the vertex form of an equation looks like this. And so it's not standard form, it's a little bit different. It looks like y equals a times, in the parentheses, x minus h. Then we're squaring outside the parentheses, and then we have plus k. And then the idea here is that you have h and k are the coordinates of the vertex. So h in the equation and k in the equation, those are the vertex. That's the vertex. That's why it's called vertex form, because the vertex shows up basically in the equation. So our learning target was to convert vertex form, so something that looks like that, to standard form. So if we want to convert vertex form to standard form, the first step is we need to follow the order of operations. Well, what we're going to find here, I'm going to jump down to number 9 real quick. I'm supposed to work inside the parentheses first. So I'm supposed to do x minus 12 first, inside parentheses, inside a group, PEMDAS GMA. But I can't perform x minus 12. I can't perform that operation. So I don't just give up on the operations like, okay, what would be next? And what would be next after parentheses or grouping symbols would be exponents. So we're going to have x as a variable. We're not going to be able to do x minus 12, or in the next problem, x plus 4. We're not going to be able to do that. So we're going to say, well, let's move on to the exponents. That's going to be our first step here. Let me freeze this and I'll write it in. Okay, so there you go. So if we want to convert vertex form to standard form, the first step is going to be to square the parentheses. Again, because I'm really supposed to do on number 9, I'm really supposed to do x minus 12 first, but I can't. So then I go, well, exponents would be next. So let's square the parentheses. Let's do the parentheses squared. Okay. So number 9 might be tricky. If you want to try it, you can pause the video, but I understand if you just want to watch me do it here. But let me get this set up. So if we're going to convert number 9, if we're going to convert this equation, which is in vertex form, if we're going to convert it to standard form, y equals ax squared plus bx plus c. 2 methods that we've seen now. We can use the box method like we did going back to how I did kind of 5, 6, 7, 8. Or we can use this formula to square the parentheses. I'm gonna do the formula first, just in case if you like the formula. If it works for you, it's pretty quick. Again, you're going to have to memorize the formula, but here we go. So first you might want to consider whether or not you physically write plus negative 12. You might want to consider that the formula is addition. So we want to think of this in terms of addition. So x minus 12 would be x plus negative 12. But the formula says you can square the first thing. Remember, it's not just square x and square the 12 or the negative 12, because there's that middle part in there. And that's to say we're going to add 2 times the first thing times the second thing. So in this case, that's a negative 12. And then we're going to add the second thing squared. Okay. And then if you simplify that a little bit, x squared is just x squared. But let's see here. 2 times x times negative 12. We can multiply 2 with the negative 12. That's negative 24. And then x comes along. And then negative 12 squared would be a positive 144. So that would be squaring the parentheses here for a number 9. We still have the plus 5. Don't forget about the plus 5. But I'm just starting by doing my order of operations to the best of my ability. Can't do x minus 12 in the parentheses, but I can do the exponent. I can square the parentheses. If you're more visual or if you don't want to memorize the formula, I'll do the box method next. Okay. But when you square parentheses, it's the parentheses times the parentheses. So x minus 12 times x minus 12. I'll write that in over here. But then, yeah, if I want to do the box method to have a visual or to have a way to organize my work, then I can just find each of the individual smaller boxes. So the top left would be x times x, which is x squared. Top right would be x times negative 12, or negative 12 times x. bottom left is another negative 12x, x times negative 12, or negative 12 times x. And the bottom right is a positive 144, negative 12 times negative 12. And then I'd add all the boxes, and yeah, x squared plus negative 12x plus another negative 12x plus 144. That's going to give me what I had over here using that formula. So keep in mind that is only the parentheses squared. We have not yet dealt with the plus 5. So the plus 5 is going to come along and say, hey, don't forget about me. But it's plus 5. It's addition outside parentheses. It's addition outside a group. So that's the last thing for us to do. So I'm going to fill in what we got with the parentheses squared. All right, so rewrote the x minus 12 squared, x squared plus negative 24x plus 144. Now, notice I'm keeping the parentheses around that. In this case, it's not going to matter if I have the parentheses, but like number 10 is going to matter because we'll still have the negative 5 times the parentheses. But in this case, you could say, well, it's 1 times the parentheses, and you could distribute the 1. 1 times x squared is still going to be x squared. 1 times negative 24x is not going to change. 1 times 144. So really, the only other thing to do here is to combine our like terms. I've got an apple pie. I owe 24 apples. I've got 144 oranges, but then I've got another 5 oranges. So my final answer here, I'll bring y back in there, but we'd have x squared. You could say plus negative 24x, or you could just say minus 24x. And then 144 plus 5 would be plus 149. And that would be it. That's our answer. That's our standard form. That's what we were supposed to do. So there we go. I just converted. I just changed an equation that was in vertex form. I changed it to standard form. I'll put some stars by this so it stands out. Doesn't get confused with my boxes there. But yeah, when you're ready, if you want to try number 10, see what you can do there. But same thing. You should start with x plus 4, but you can't. So square. Do the exponent. Square the parentheses first. Try it out. And then when you're ready, you can unpause the video and take a look. This time I'll start with the box method. So if you're doing the box method, remember x plus 4 squared is x plus 4 times x plus 4. And if you break it down into all those individual boxes, x times x is x squared. We'd have a plus 4x, another plus 4x. 4 times 4 is 16. And we would add those all up. X squared plus 4x plus another 4x plus 16. We could combine the 4x with the 4x. That would be 8x. We have an apple pie, 4 apples and 4 apples makes 8 apples and 16 oranges, okay? So now keep in mind, I'll do the formula also, but that's just the x plus 4 squared. We still have that minus 5, that negative 5, that we'll have to consider here. But I'll get there in a moment. So for those of you that like the formula or want to try the formula instead, you should get the same thing as what I got with the box. But I'll pause it here and you can try it if you want. So again, the idea with the formula, it's not just x squared plus 4 squared. That's a mistake. X squared is part of it, 4 squared is part of it, but there's also, besides squaring the first thing and squaring the second thing, we also have to add 2 times the first thing times the second thing. So we've got the x squared plus 2 times x times 4. Well, we can do 2 times 4 is 8, and then also times x. And then 4 squared would be the 16. So that's the same thing we got doing the box method, which is good. But again, if you like the box method, go for it. If you like the formula, go for it. But we need to say that that's only x plus 4 squared. We got to still account for this negative 5. So I'll do that next. Okay, so here we go. So all I did now was I changed the x plus 4 squared to x squared plus 8x plus 16. Again, notice I kept it in parentheses. Back up here we said, if you didn't use the parentheses there, you're okay. But that's because it's 1 times the parentheses. And we don't need to specify that we're multiplying by 1. But when you're multiplying by negative 5, that is important to note that you're multiplying by negative 5. And it's the whole thing times negative 5. So this is where I'm just going to now distribute that negative 5. Everything will get multiplied by negative 5. So we'll have, to get our final answer here, y will equal negative 5 times x squared. Then we'll also do negative 5 times 8x. That's going to be negative 40x. And then also negative 5 times the 16, I believe that is negative 80. Yeah, looking at my cheat sheet here, that's what we have. And that's it. Remember, I owe 5 apple pies, I owe 40 apples, I owe 80 oranges. this doesn't simplify anymore. There's no like terms. I'm not going to be like, well, -5 minus 40 is -45. I go, it's apple pies and apples. Leave them separate. We're done. That's it, except to box in my answer, perhaps. Make that stand out, again, with the box method. I'll add some stars here. But yeah, that's it. So number 11 kind of combines what we did in number 9 and number 10. Number 9 had addition after squaring the parentheses. Number 10 had multiplication after squaring the parentheses. Number 11 has both. We've got the x minus 9 squared, but you have 7 times that, and then you have minus 20 afterwards. So number 11 is kind of a combination of what we did on number 10 and number 9. But yeah, if you're ready, if you want to pause the video, see what you can do with number 11, and then you can check here. Here I think I'll go back, I'll do the formula first again. So again, remembering that the formula, if we go back to the bottom of the last page, the formula talks about addition inside the parentheses, whereas number 11 has subtraction. So we go, oh, that's an easy fix. Instead of saying we're subtracting 9, we can instead say we're adding -9. But the formula says we're going to square the first thing, so square x. We're going to add 2, a 2 is just part of the formula, times the first thing, times the second thing. Second thing was a -9, that's important. And then we're going to add the second thing squared. And we can do a little bit of simplifying there. X squared is just x squared, but 2 times x times -9, we can multiply 2 with -9, that's -18, also times x. And then -9 squared is -9 times -9, that's an 81, positive 81. So that's the parentheses squared. I'll do the box method also in case you would prefer that. So the setup for the box method might look like this, and then I can fill in the area of each box, base times height or length times width. So the top left would be x times x, which is x squared. Top right, x times -9 or -9 times x. Bottom left, -9 times x or x times -9. And bottom right, -9 times -9, which is a positive 81. We add all the boxes. So x squared plus a -9x. Plus another -9x. By the way, that's where the 2 comes from in the formula, is because this box and this box, you have 2 boxes that are going to be identical. But then we also have the plus 81, and we can simplify that. We can add the -9x and the -9x, and we end up with x squared plus -18x plus 81. So again, this 7 I still have to think about. I haven't done anything with that 7 yet. The -20, I haven't done anything with the -20 yet. So all I'm going to do right now is I'm going to change the parentheses squared to the x squared plus -18x plus 81. So once again, still that result of squaring the parentheses, I kept it in parentheses. We saw where number 10, that was important. Number 9, we said, if you didn't put x squared plus all that in parentheses, you'd be okay there, but that was only because it was 1 times the parentheses. If it's -5 times the parentheses, I need the parentheses. So everything gets multiplied by -5. 7 times the parentheses, I need the parentheses so that everything here is going to get multiplied by that 7. So I'll do 7, I'll distribute the 7, it'll be 7 times x squared. It's just 7x squared. I'll do 7 times a -18. I could say plus, looking at my cheat sheet here, that is -126x. I'll do 7 times the 81. That is 567. I do not do, sorry, let me rewrite that. I do not multiply 7 times the 20 or the -20 because that's not in parentheses. So that just hangs around and says, hey, let me know when you're done doing the multiplication. So now I'm sitting at one more step. I got 7 apple pies. I owe 126 apples. I have 567 oranges. And then I owe 20 oranges. So we can combine these 567. I'll just say minus 126x here. But these can combine, and that's going to be plus 547. So there you go. We've got standard form now. One thing I forgot to say on this one. I think we've seen it before, but maybe I'm wrong. This right here, this is pronounced f of x. It's something called function notation, but you can effectively just replace it with y. So you could say, you could say f of x equals all that, or if you want, you can just say y equals all that. But I'm just going to box this part in. But yeah, there's my standard form. There's ax squared plus bx plus c. So hope that video was helpful for you, and see me in the next one.